Alright, welcome back guys. We are in 11.2 for properties of parallel lines. This is actually instances that you encounter more often in real life, or at least that you notice more often in real life, where there's a transversal to a set of parallel lines. So here we have lines L and M parallel to each other with our one transversal, which again makes 8 angles. But what gets really fun here is our same side interior angles postulate, which says angles on the same side of this, such as 4 and 5 being in the interior, because they're an interior pair, they add up to 180, and so do angles 3 and 6, also same side interior. We can look at some other postulates, but we'll get there in just a minute. So here in examples 1 and 2, I love utilizing the fact that we have parallel lines cut by a transversal to prove other angles. We can see that 7 should be equal to 51 because they're vertical angles. They're comprised of the two same lines and they're opposite to each other. So those would both be 51 degrees. And because of corresponding angle relationship, 51 and angle 5 are the exact same angle because they're both to the left of the parallel line on top of the transversal. So 5 is equal to 51, and likewise 4 is, because they're vertical. So then we can make a supplementary angle pair here with the 51 degrees and angle 1. So we can say that 1 is the supplement to 51 degrees, which means that angle 1 would have to measure 121 degrees. Scratch that, 129 degrees. Sorry, saw the font difference and got a little goofed up there. So check out example 2. Make sure that you can solve it. You would probably want to start by pairing up angle 120 with angle 5. And then from there move on and find out what you know about everything over here in 1, 2, 3, 4. So I wanted to show you guys another way to write this. It's a little hard here on the computer, but this symbol we use for the measure of how large an angle is. So if we ever write this, and then you normally put like a number, like the measure of angle 5 here, or you can write it the measure of angle. So when you're writing it, you don't always have to write it out with words. So when we look at the measure of angle 5, since it's the supplement to 120 degrees, has to add up to 180, so that makes it 60 degrees. From there, we could see that angle 1 is in the same location, so it would also have a measure of 120 degrees, as well as angle 3, because they are vertical angles, which then we can again derive 2 and 4 based off the supplement, or the same angle location, which means that angles 2 and 4 are also 60 degrees. So we're going to walk through the proof of alternate angles being the same. So our alternate interior angles theorem. So if we have two parallel lines, L and M, cut by a transversal, then that is our given statement. L and M are parallel. Then we can know that 3 and 4 add up to 180 because they're a supplementary pair. We can also say that angle 3 and angle 6 add up to 180 degrees because of our same side interior angles postulate. If you don't remember that, it's where you think about sliding this line down, and then they would be supplementary because these angles would be corresponding. We then talk about 3 and 4 equaling 3 and 6 by our transitive property of equality. Through subtraction, we can remove angle 3 from both sides and get that angle 4 is equal to angle 6. And since they are the same measure, then those two angles are said to be congruent. So example 3 here wants us to prove that angles 1 and 8 are supplementary when our given is that A is parallel to B, and then we have a transversal cutting both of them. So go ahead, start setting up your 2-column proof. We want to have a reason to support every statement, and we always start with the given. So I'm going to start this proof by stating that angle 1 is equal to angle 5, and that would be because they are corresponding angles of parallel lines. Are both on top of the parallel lines to the left of the transversal. We're then able to say that angle 5 and angle 8 will add up to 180 degrees because they are a supplementary angle pair. I can then state that angle 1 plus angle 8 would be equal to 180 degrees because I've already made the statement about 5 and 8, and I know that angle 1 is equal to 5, so all I do is substitute in since these two things were equal. That then proves that angle 1 plus angle 8 are supplementary. So then we have theorem 8 based off of that. Angle 1 and angle 7 would be congruent, and angle 2 and angle 8 would be congruent. We can use that here in example 4 to find out the angles 3 and 4 measures. So go ahead and figure out what is angle 3 and what is angle 4. So based on the alternate interior angles theorem, we know that angle 105 and angle 3 are the same. If you need a reminder, that's because 105 is equal to angle 7 through vertical angles, and then 3 and 7 are corresponding. So that means angle 3 is 105 degrees. In a similar fashion, angle 105 and angle 4 have the relationship of being supplementary because 4 would be corresponding to this angle right here. So that means in this situation it is 75 degrees. So here in examples 5 and 6, go ahead and pause the video, make sure that you can solve for angles 1 and 2 in both situations here. They do not have to be the same measures. Angle 1 here and over there, they do not have to be the same. What I see here is because I have a supplementary pair, I have angle 2 equal to 105 degrees and angle 1 in a same side corresponding pair, we have the same measure. We know that angle 1 is supplementary with this 80-degree angle because of our theorem, but if you need help remembering, that's because if we extend this line this way, the angle that we would see right here would be the supplement with angle 80, and that is corresponding. So we know that angle 1 measures 110 degrees. And then because of that, angle 2 is angle 1's. Well, we have to be careful here since we don't know if AD and BC are parallel, so make sure that you've analyzed what needs to happen here. So, since AD and BC are not parallel, we just look at the situation of my parallel lines and its transversal, ignoring over here, and what we see is that my alternate interior angles would be congruent. If you need help visualizing that, there you go. Go ahead and try A down here, then come back for the answer. We're actually going to skip that example and come over here to talk about angle combination. So if we look at this situation, we have our parallel lines right here. Our parallel lines and our transversal. And then we can actually match up my 80-degree angle here with my Y and my 40-degree angle, because then they would be the interior pair, which you should remember by our theorem have to be supplementary. So if we write the whole thing out, we can write out our equation just like this and find out that the measure of y must be 60 degrees. So now we're going to tackle this problem, so don't worry if you did that one before, it was not in vain. It might help to extend out some of these lines to be able to visually see that, so go ahead and try that if you need a little bit of help. So then finding our same side interior pairs of our two different transversals, we can set up two different equations. I actually have the sides kind of flip-flop here, but from my left side we see that 2x plus the other expression for the angle x minus 12 would add up to 180, and likewise 3y and the expression y plus 20. So then we can combine like terms and solve. So take a moment to do that, come back only for the answer. I'm not even going to type out the solution. And then because x and y are in an expression that make up a degrees, you do not even need a degrees symbol on them. That is all I have in the notes for you guys today, so please let me know if you have any questions, comments, or concerns about this topic, and I will get on it right away. Please make sure you work through Pearson and give your homework a shot. Have a great day.